Dr. Stone is a science anime where the main character rebuilds civilization by making countless inventions. In this series, we'll be going over the science of the inventions and debunking whether they'd work in real life, going over the physics and science behind it all. Here are the inventions covered in this video. Now, to tackle the steam engine, we use the Planck equations, where P is pressure, L is stroke length, A is area, and N is strokes per second. Now we can look at a clip of the engine in action, and we can estimate how many revolutions it takes. It's a little cut off, but you can see it right here. Looking at that clip, we can estimate that there's about 18 revolutions in 4.7 seconds, so it'll end up being 229.79 revolutions per minute. Then looking at a picture of it, the piston's occupied area is about the size of a hand, whose diameter is roughly 19.3 centimeters. So we take a circle area equation to find the area. The length is about 1.5 times the length from the elbow to the hand, which is about 43 centimeters, so 64.5 centimeters. Anyways, since they're using a furnace to heat everything, Gemini says to estimate the pressure at around 45 psi, since it's encased in iron and bronze and all. So we take all our equations from earlier and plug them into the power equation to get 301 horsepower, which is comparable to a Toyota Camry, surprisingly. So we can look at how fast the wheels are spinning in the clip to find the gear ratio drops down the revolutions per minute to 105 RPM, and velocity is equal to RPM times 2 pi times R, with R being the radius of the wheel. It will end up being 48 centimeters. Then V is 316 meters per minute, or 11 miles per hour. Anyways, pigs run at about 11 miles per hour too, and it's like a 530 mile. Next up is the carbon fiber shield. Well, it's actually fiber-reinforced plastic, but carbon fiber sounds cooler. Just like concrete with rebar, the polymer of the plastic gets reinforcement from many fibers that surround itself around. The chemical formula stems from mixing phenol from plastic and formaldehyde from plants to make a phenol ring that's extremely sturdy. It undergoes losing a water molecule, which is called hydrolysis or dehydration as in the picture, to separate into a polymer. Then to find its strength, we use the material science rule of mixtures and compare the plastic and resin. Then we do our calculations, skipping some stuff, and it's just sigma C times A. Next up is bleach. So bleach is actually manufactured in plants by bubbling chlorine through sodium hydroxide and then diluting it. But Senku needed a super strong one, so he mixed water, salt, and electricity to separate everything. An electrolytic cell, which you learned in the last video, you could separate the gases and then mix them in the water to make bleach. Now for the tank bullet. It's a standard chemical energy round made up of sulfuric acid, alcohol, and sparks. When fired, it triggers multiple reactions that need different activation energies, so the sparks all combine it to set off one another. You can see the delta H escalating as the energy ramps up in the payload. Now for the stun gun. Senku made a circuit that essentially took a bunch of batteries and used an iron inductor which ramps up the voltage by utilizing a powerful magnetic field. Technically, it's a bunch of vector calculus, but I'll squish it down to this. The iron domains make a magnetic field, and then that makes a flux for anything traveling in it, which creates an electromagnetic force as it travels through. And that's it. No calculations since most of it was hidden. Anyways, thanks for watching.